So welcome. This is 10.3 on matrices and systems of linear equations. This is just an extension of the last section. Okay, so math-wise, um, we're dealing with the same stuff. All right, it's just a different way of thinking. So your essential questions for today are: what is a matrix? And how do I use matrices, or the plural version of matrix, to solve a system of three equations, three variables, and three equations, right? So here, what is a matrix? A matrix is just an array of numbers, okay, with number of rows here, right, going up and down, and a number of columns here, going side to side, and we label it by going row by column. Okay, it's row by column. All right, that plays an essential role. Role, ROLE, when we are talking about like multiplication of them. Okay, so the dimensions are going to be that. All right, so it's just um, and a way to label them are here. So this matrix is a two rows and three columns, right? So it's 2 by 3. Here in this matrix, we have one row and 1, 2, 3, 4 columns, right? So it's a 1 by 4. All right, pretty simple. Okay. And how we use it to solve systems. Okay, so this is your linear system that we've been dealing with, right? Yeah, like a 3x minus 2y plus z equals 5. And there's three equations and there's three variables system. What we're gonna do in order to make this a matrix is we're gonna get the coefficient of everything and just put it in this type of matrix. Okay, so look at that first equation or first row. 3x minus 2y plus 1z equals 5. So 3, 3, negative 2, negative 2. The coefficient of z is 1. So that's 1, 5, 5. Okay, so you can think of this augmented matrix as x, your x coefficients, your y coefficients, your z coefficients, and this is the equals, and this is just a number, right? And that's what happened for both equations there. Okay? And remember what we want to do. We can add, we can subtract, we can multiply, right? To eliminate the variables, right? And just like the steps from before, you want to get rid of this one. You want to make it a 0 and this one, right? These three numbers, you want to make a 0. Okay? And we're going to go over the steps by doing one example. Okay, of that. So the math-wise, it's the same. Remember in the first semester where we long divided, yeah, two polynomials, and then we went over how to synthetically divide just by taking the coefficients, dropping them down, adding it, multiplying it, right? Same thing. Essentially, the same type of math that we're doing. Okay, we learned the long division part, right, which was the previous section where we got the x, y, and z, and we did all that math. This is the synthetic part. Okay, so it's kind of just organizing your work differently, and we're gonna get the answers by getting those three as zeros. Okay, so this is your example. This is your linear equation, right? Linear system, not linear system, your system of equations, right? And if I take this and I put it in terms of a matrix, my matrix would end up looking like 4, 8, -4, and 4. You're just getting the coefficients of that first equation, and you're putting it in your first row. 3, 8, 5, -11. Same thing. Second equation, second row. Third equation, -2, 1, 12, and -17. Right? Third equation, third row. Right? So now, your first step, class, you can multiply, add, subtract. No, I don't want to subtract, but you can subtract or divide. Okay? So just for labeling purposes, I'm going to label this row as row 1, this row as row 2, this row as row 3. Okay? So whenever I say row 1, I'm referring to this row here. If I say row 3, I'm referring to this row here. I already noticed something that I can do, right? Because it's easier for us to deal with smaller numbers rather than bigger ones. So if you look at the first row, they're all even, right? They all can go into 4, correct? Yeah. So before I even try to do my zeros, I'm going to make that smaller. I'm going to make that 1 dividing everything by 4. So what I did was I'm going to go row 1 divided by 4. 1, 2, -1, +1. I'm going to keep everything else as is. So 3, -2, 8, 1, 5, 12, -11, and -17. Make sense? Yeah. Now 1, 2, -1, and 1, this row, for the first row, is easier to deal with than 4, 8, -4, and 4. Yeah? Now my next step, after I kind of look at it, I want to get these two as zeros. Okay? Let's focus on one of them. Let's focus on this one here. What am I going to do to make that a 0? Can't I just go 2 times row 1 plus row 3? Yeah. If I multiply 2 times 1, that's 2, plus -2, that's a 0, right? So if I use this as my base, right, as my equation, I can get rid of this 0, right? I can make this -2 a 0. Questions on that? No? So Let's perform that. But before I do, I'm just gonna write that first row down here. 1, 2, negative 1, 1, because I'm not gonna do anything with that row. Okay? So negative 2 times 1 plus negative 2, that's a 0. Negative, or 2 times 2, which is 4, plus 1, right? 4 plus 1 is 5. So that's my new third row. Negative 1 times 2, or 2 times negative 1, which is negative 2, plus 12. Negative 2 plus 12, that's 10. Right? 2 times 1, which is 2, minus 17, or plus negative 17. 2 minus 17, that's negative 15. Correct? Does that make sense? Yeah. How do I get rid of now? This one. Can I go negative 3, row 1, plus row 3? Negative 3 times 1, that's negative 3, plus 3, that's a 0, right? And honestly, as long as these two guys are zeros, I don't care about the rest. Yeah? Let them fall wherever they fall. Okay? So negative 3 times 2, that's negative 6, plus 8. Negative 6 plus 8, that's 2. Negative 3 times negative 1, that's positive 3, plus 5, that's 8. Negative 3 times 1, that's negative 3 minus 11. Negative 3 minus 11, negative 14. Okay? So I got that one, right? Now again, class, with the last two rows, the green row and the red row, the second row and the third row, there's something I can take out, right? So the green row here, they're all even numbers, 2, 8, and negative 14. So I'm just gonna divide it. Let's go row 2. Oh no, class, I made a mistake here. This is not row 3, this is row 2. Right? We didn't make the mistake with the math, I just mislabeled it. Row 2 divided by 2. So my new row 2 will be 0, 1, 4, negative 7. That's easier to deal with than this guy. That's why I'm doing this. Okay, just for future math to be easier. And the third row, they all can be divided by 5. So let's do that. Row 3 divided by 5. So that's a 0, 1, 2, and negative 3. Right? My first row, I do not touch. Okay? Questions on that? No? So we're almost done. Okay, now I need this to be a 0 in order for me to get all 3, right? I want all of those 3 to be a 0. So How do I get that? How do I make that a 0? Yeah. Why do I need those three to be zeros? Because if I plug this back into the XYZ, because this is a system, right? Then if those three guys are zeros, then I would have, for example, 2z equals -3. I can solve for z. And then once I solve for z, y plus 4z equals -7. I can plug in that z value into this to get y, right? And then plug in y and x, or y and z, to get my x value from the first one. So it's the same, the warm up that we did. We're trying to get there last class or last lesson. Okay. So here I can just go row 2 minus row 3, right? Yeah. I can just subtract those two. 1 minus 1 is 0. And the reason why we use row 2 and row 3, and why we have to use row 2 and row 3 and not row 1, is because row 1 has this one x value. Okay? If you do anything here, you're going to mess this 0 up. Does that make sense? This is no longer going to be a 0. It's going to be whatever you're adding 1 to, or you're multiplying 1 to. Yeah? So you cannot use row 1 here. You have to use the two new equations or the new rows that you made, that you created, just like the last lesson, right? We solve for a variable, we solve for a variable. The two new equations you use to solve for another variable, or you cancel out a variable, right? Just like the same way, we have to use the new ones. Okay, so row 2 minus row 3, that would be 0 minus 0, which is 0. 1 minus 1, which is 0. 4 minus 2, which is 2. And -3 minus -3, or minus -7, excuse me, -7 minus -3, that's a +3, so that's -4, right? And just rewriting first two, yeah, that would be it, right? And now that I got my zeros here, and here, that triangle that we were talking about, right? We got that 0. Now we're ready to solve. So because this is my z value, this is my y value, this is x value, and this equals the number, right? I can say that 2z equals -4, right? So 2z equals -4, so z equals -2. I got my z value. Taking my z value, 1y plus 4z equals -7. So y plus 4z equals -7. Plugging my z value into here, that would be y plus 4 times -2 equals -7. That's y minus 8 equals -7. Add 8 to both sides, and we get y equals 1. Okay, so with y equals 1 and z equals -2, what we're going to do is plug it back into that first one. Okay, so that's x plus 2y minus z equals 1. So that's x plus 2 times x plus 2 times 1 minus negative 2 equals 1. This would be x plus 2 equals 1. X plus 4 equals 1. So x is going to equal negative 3. Right? So you got your x, you got your y, you got your z. And that is your answer. Negative 3, 1, and negative 2. Okay? Yeah. That second row. This one? That first row. Y is negative. Y is 1, yeah. No, I solved for y here. I only took a few numbers from the second row. Yeah, because 0x is just 0x. I don't need it. Plus 1y, which is y. Plus 4z. X plus 2, y. This one? Yeah. All right, so that is the lesson for today. Thank you, and I'll see you on the next one.